Hey guys, thank you so much for having me today. My name is Eggerman and I'm a neuroscientist. So a neuroscientist is a scientist that studies the brain. One of the really cool things about science is that you don't have to know everything about all sorts of science. You just find one thing that you're really passionate about and that's all you have to pursue. So for me, there are all sorts of scientists out there. You know, meteorologists every time there's a hurricane that comes through, marine biologists if you go to the Loggerhead Marine Life Center, anything like that. You're not going to ask me questions about turtles. You're not going to ask me questions about hurricanes. You're only going to ask me questions about the brain. That's kind of the fun part about being a neuroscientist. You just get to pick what you love. My name is Erica Eggerman. I am the Education Outreach Coordinator at Max Planck, which means that my job is to come out and communicate science to students from K through 12. I have my bachelor's degree from Boston University, and my degree's in biology. After I finished my undergrad, I decided I'm not really sure what I want to do next. So instead of pursuing a higher degree, I decided I was going to get into the workforce. So I started at a lab in Scripps over in Jupiter. You'll notice it's kind of far away from Boston. It's because it was a better opportunity for me, so I went ahead and pursued it. And I took a 2-year job. You'll see up there I stayed for almost 10. And my research interests are the molecular mechanisms of learning, memory, and forgetting, animal behavior, and emerging biotechnology. So, has anyone ever heard of Max Planck before today? Okay, I didn't expect you to. So the Max Planck Society, it's something that almost no people in the US know about, and that's because we have institutes all around the world. We have 86 of them to be precise, and most of them are in Germany. We are the only Max Planck Institute in the United States, and we're the only Max Planck Institute that will ever be in the United States, so it's pretty special that we're right here. And in the society, I said we have 86 institutes. So our institutes, we all study something different. So mine is the Max Planck Florida Institute for Neuroscience. We study the brain. There are about 12 different institutes that study the brain in different capacities. But there are all sorts of institutes out there. There are some that study art history, some that study criminal justice, some that study moral courage. Really anything you could think of studying, there's a Max Planck for that in Germany. Throughout all of our institutes, we have 31 scientists that have won Nobel Prizes. And we have 15,000 publications, 15,000 discoveries published every single year. And the Max Planck Society is ranked the #1 organization in nonprofit biomedical research in the world. So it's pretty incredible that it's an hour's drive. It's really not that far away. It's in your backyard, it's in your county. So you might say, why do all of these institutes that all study wildly different things, like neuroscience and art history, really different, right? The reason we all unite is under this one principle of insight must precede application. What that means is that you can't fix something until you know how it works. Think of a car. I'm not going to be able to make it run properly if I have no idea how the engine works. So that's the main message behind all of our work. We do what's called basic research. And basic research might sound easy, basic, but what it means is it's fundamental research. We want to know the hows and whys of how our brain works, because when it comes to disorders like Alzheimer's disease, we want to know how it's supposed to work, so when it's not working properly, we can probably figure out how to fix it. At my institute, we have 9 different group leaders. A group leader is someone who runs their own lab. They have all different specialties, all different things that they want to really pursue, and they have a lab that supports them. So they have a team of scientists that furthers their goal. They're the people that get all the funding for it. So I bet you guys don't know how funding works in science, right? Why would you? So when it comes to scientific research, the only way that we get paid is if the government funds our research. So all research is nonprofit. So we don't make any money off of what we do. All of what we do is to try and better humanity. It's to try and get more information so we can cure more things over time. And the only way we can do that is if the government thinks, hey, this is a good idea, let's support it. Or if a donor thinks, hey, this is a good idea, let's give you some money. So all of these group leaders, their job is to get that funding to make those discoveries so that they can hire more scientists to continue to make more discoveries. And then we have 4 different scientific cores at my institute. And the 4 different cores are a mechanical workshop, a light microscopy core, an electron microscopy core, and a molecular biology core. The reason we have these 4 things is because science is hard. And when it comes down to it, I have a lot of techniques that I don't know how to do. I don't know how to use an electron microscope, and they cost about $3 million. So I don't want to try using it without an expert with me, because if I break something that's $3 million, that's going to be the rest of my life paying that off. So what we have is we have a team of experts that have trained in every single technique to use these pieces of equipment. And what our scientists do is they say, okay, I need this image. Your time is precious. You don't want to learn how to do the technique. It might take you years. Your sample is precious. You've put all this effort into collecting it. You want to make sure that you don't ruin it because you don't know how to use the machine. So you go to these experts and they do it for you. They're at the top of the industry, and they're really fantastic people to work with. But the one I really want to point out to you, and I'll circle back to it in a little bit, is our mechanical workshop. So science, I didn't know this when I started in a lab, but if you're going to be at the cutting edge of science, the tools that you need don't exist yet. You have to build them. And I don't know about you. You guys are looking at me right now. Does it look like I know how to use power tools? No. The first day that I was in a lab, I was asked to use a bandsaw. So that was an interesting experience. So our mechanical workshop, we have mechanical engineers and we have a bunch of machinists. And they are able to build all of the parts that we need. And we come in there with some crazy stuff. We come in and say, okay, I need something that can be at negative 20 degrees Celsius. It needs to hold my sample at a 45-degree angle, and I need to be able to submerge it in acid. How are you going to do that for me? And they'll figure out how to make it for me. So I'm here to talk to you about my research with the brain. So the brain, we have billions of neurons. A neuron is your brain cell. And we have trillions of synapses. Synapses are the connections between those brain cells. So when I say billions, to be precise, it's about 86 billion neurons that are in our brain. Can you guys go ahead and take two fists together and put them in front of you, just like that? That's roughly the size of your brain. You have 86 billion neurons, 86 billion cells in that small little area. And they're making trillions of connections. It's the most complicated living structure in the known universe, and we're really just scratching the surface when it comes to understanding how and why it all works. So your brain, you all know, is important. I don't think anyone's going to try and fight me on that one. But it's responsible for a heck of a lot. Not just controlling your body, things like your heartbeat, your breathing, telling you your circadian rhythms, when to be asleep, when to be awake. But it's also responsible for your decision making, your moral judgment, if you think something's a good choice or a bad choice, your emotions, and your attention, your memories. In a real way, you are your brain. Your brain is the essence of who you are. But then, I think once this list goes up in full, you'll notice we have a tremendous number of disorders that can affect your brain. So can you raise your hand if you know someone that's been affected by one of these disorders? It's quite a few of us. I think almost everyone knows someone that either has a bipolar disorder, autism, Alzheimer's disease. It's really pervasive. There are over 1,000 disorders that affect the brain. Over 700 million people are affected, and we spend on average $1.5 trillion a year trying to treat them. So that's just a little bit about why I do what I do and why I feel like it's so important, because I know that I've been affected by several of these disorders in my life and in my family's life. So the first thing I'm going to talk to you guys about today is a neuron. So that's what I was telling you about before. When you have your hands together, you have 86 billion of these cells. You have 86 billion neurons. So the neurons, there are a couple different parts. On the outside, you'll see the dendrite. It's kind of looks like tentacles that are reaching out. Your dendrite is the listening part of the cell. It's reaching out, trying to make connections with other neurons so that it can pass messages. You have the soma, or the cell body, that's in the middle. That's kind of the computer of the cell. It checks in to make sure if the message is important enough to send to the next cell down the line. You'll see the axon, which is kind of what hangs off the end there. It's kind of the highway of sending a signal onto the next cell. And then you're going to see the axon terminal at the end, and that's what makes a connection with the next cell's dendrite. So the way our brains work is basically by using chemical and electrical signaling. But our neurons don't work by themselves. So we have a single neuron, which we need to figure out how are these messages being sent. Then we have all of the neurons working together. And these pictures here, these are actual microscopy pictures. These are pictures that my friends at the Institute took. So you'll see just how dense it is, how many neurons are in that one little spot, how they're connecting so that they can interact together, and then how abnormal connections change our behavior or change our diseases. So you guys might have seen before a brain scan, somewhere on TV, in a textbook, something like that. And you're probably thinking of a functional MRI. So what you can do, you can take a human patient, you can take anyone you want, you can pop them in a functional MRI, and you can show them pictures of their childhood home. And the emotional center of their brain is probably going to light up because it's something that really triggers something deep inside you. You can give them a math problem, and a different area in their frontal lobe might light up because they're doing problem solving and that's where that region's located. You might ask them to speak to you, and then Broca's area, which controls speech, is going to light up, which is all great and gives us a lot of information, but we're talking about centimeters. You can see how big that spot is there that's lit up. And that's millions of neurons. So it's interesting, but it doesn't give us very specific information. So what we're tasked with is trying to figure out how to make that information more specific. We want to know exactly which cells are lighting up, not just the whole panel. And that's where we have what I have up here. So you'll see that these cells are all lighting up, and they're lighting up individually. So these cells here, you'll notice that there are some lines that are showing up here. This subject is being shown the little screen that's up in the left, in the top left, yeah. And you'll notice that when the lines are vertical, one specific area will light up. When the lines are horizontal, a different area will light up. They're lighting up because we have this really cool technology that basically it will make the cells glow only when the cells are passing a message. So using this, and using this microscopy technique, we can see exactly which cells are responsible for determining orientation. So you guys don't need all this part. But it's pretty impressive that we can see exactly where these cells are lighting up and see the network of the group of all of them that are lighting up at the same time. So now I'm going to talk to you guys about my absolute favorite technique. And I'm going to tell you about it because essentially it's mind control. I got to put people's attention for that one. So I told you guys I do basic research. I do research that probably if I told you exactly what my experiments are, you're going to say, who cares? So I'm going to tell you the story of how this came to be because it's going to be one of those who cares stories until it's not. So a marine biologist was really interested in this one kind of algae. Because this one kind of algae, whenever it was exposed to a light source, it always swam towards the light. He really wanted to find out why. Who cares? What he ended up discovering is that it had this little protein in it called an opsin protein. And when this protein, it's a membrane protein, when it was exposed to light, it would open, it would flood the cell with calcium, and it would force it to fire, which would make it move. Again, it doesn't sound super important, but what we can do with it now is we can take this little protein, take the gene that causes it, and now I can put it in whatever cell I want. And how cells work, I told you, is chemical and electrical signaling. When we put this protein on whatever cell we want, we essentially give it a light switch. So if it's exposed to a light, it's going to flood the cell, which is going to make it turn on and fire, and then we can basically control what activity is happening. So all I have to do is I have to expose it to, in this case, a blue light, and when it fires, it's going to basically override whatever the cell of the animal wants to do, and it's going to make it do what I want it to do. So pretty cool. And this technology, just as a heads up, this discovery was made about 18 years ago. In science, if you told someone about this 20 years ago, that we're just going to be able to turn on a light and it's going to do what we want to do, they would have told you that it was from Star Trek. That's how fast science moves. And now it's a technique that every single one of the labs in my institute works with. So when it comes down to it, I now have this mind control device, basically. Are your parents going to sign permission slips for me to use it on you? No, of course not. Maybe some people. So what we have to do is we have to use something called a model organism. So a model organism is an organism that has some structure or function that's kind of sort of similar to us. When it comes to my favorite model organism, it's Drosophila melanogaster, also known as the common fruit fly. So you guys have all seen it in your kitchens when bananas get too old, buzzing around trash cans, anything like that. But these little flies, they've been studied for over 100 years. They're about 70% genetically similar to us, which a lot of people find very surprising. Again, we're about 33% genetically similar to a banana. So anytime you're feeling a little high and mighty, you're 33% a banana. But the reason we want to use Drosophila is because they have a really short life cycle, so I can study many generations at a time. They can lay a ton of eggs a day, so I can have a huge population size to work with. There are a lot of different genetic tools I can use, including this optogenetics that I'm telling you guys about right now. And they're really cheap. I can keep them forever for very little money because they just need a little bit of fruit, a little bit of sugar, and that's all you need to maintain them. So this is what I actually worked with for all of my time in bench science. The whole time I was working, I only worked with fruit flies. So in fruit flies, the lab that I have at Max Planck that studies fruit flies, they study motion. Because your brain, your body doesn't just move. Your brain's telling your muscles to contract. Your brain's controlling your motion. So in fruit flies, we know exactly what neurons are responsible for causing them to move in different directions. So we know which cells are needed to walk forward, to walk backward, to stop, to sprint. And we can control how and when these things happen. So I'm going to pause this one. So I have two things up here. We have the moonwalker neurons and the bolt neurons. The moonwalker neurons, I told you we're going to control what direction they walk, right? What direction do you think the moonwalkers are going to walk? Backwards, very good. So fly scientists, we play with bugs all day. We have to have fun somewhere, so we do it in naming things. So the moonwalker neurons, our scientists, they thought they knew all of the cells responsible for backwards walking. They used this optogenetic technique to put that light-controlled protein only in those cells. If they're wrong, if they missed a cell, when they turn the light on, they're not going to walk backwards. So it's really to prove concept, to make sure that they know all of the things they think they know. So you see this red light up in the corner. The red light means a light is being flashed on them. So let's see. You'll notice as soon as the light starts, that fly starts walking backwards. Now, it's more impressive when you see it from the beginning. So it's just sitting still, it's grooming itself. Fruit flies like us, they don't really want to walk backwards. I mean, how much do you do that in a day? They can, but it doesn't help them. But this fly, as soon as we turn on the light, it will start walking backwards, and as soon as you stop shining a light, it will go right back to normal. All right, so my other one over here is the bolt neuron. What do we think the bolt neuron does? It makes them sprint. It was after Usain Bolt, that's how they named it. And same thing, as soon as that light stops, it goes right back to normal. You can see he's just sitting there minding his own business. But we can do this for stopping, starting, going right, going left. We now know all of the different cells responsible for moving in any direction. You might say, who cares? I understand it's basic research, but when it comes to making a prosthetic arm for someone, we need to know what cells are responsible for moving your thumb. So then we can make a prosthetic that senses those signals and then moves the prosthetic the right way. So the field of robotics is very interested in this work, as are we. But that's my little magic trick. Sometimes I can bring the flies out with me. I don't have them today, unfortunately. So the next thing I want to talk to you guys is about some opportunities in research. Because I understand that science can seem unattainable sometimes, and it can seem like it's kind of up in an ivory tower. So I'm going to talk to you about some of the different people that I work with today. So when you think of scientists, you think of my friends here. You think of the researchers. Here we have a research group leader. Again, we mentioned earlier, those are the people that run a lab. They have a team of scientists that are supporting them. Next, we have a postdoctoral fellow. That's someone who already went through their PhD. A PhD can take anywhere from 5 to 8 years, depending. But important to know, when you're getting your PhD, you're being paid that entire time. So getting your PhD is not something where you're just going to hemorrhage debt. It's not like medical school. It's not like law school. You are paid the entire time. So that 5 to 8 years is a little less scary when you're through that part. And then we have a PhD student. So she's still working towards her thesis. She's working on, basically to get your PhD, you need to have one big discovery, one big publication. And so she's still working on that now. And then I like to tell you about someone who took an alternative path. So all my slides, I'm going to talk to you about the normal way people do things and then the abnormal way. So when it comes down to it, I'm the abnormal way when it comes to research. So I don't have my PhD. When I was introduced, I was Mrs. Erica. I was not Dr. Erica. And that's because I got my bachelor's. And then I wasn't sure what I wanted to do. How many of you are 100% sure what you want to do when you're done with school? Just a couple people. I was not 100% sure. When I was in high school, I knew that science was cool. I knew I was good at science, but I didn't know how I was going to make that into a career. So I decided before I pursued my PhD and decided I was going to spend 5 to 8 years doing something I wasn't positive was the right fit for me, I was going to get a short-term job at a lab and see if I enjoyed it. And of course, you guys already heard, I tried it, I loved it. It's what I was put on this earth to do. So I ended up staying there for 10 years. I have published papers, I have made discoveries. I am a field expert in several techniques that people with their PhD, people that are in their 60s, email me still to this day to ask me how I do certain things. So you don't have to go any certain route. There are plenty of ways to do science, and I hope to show you guys that in the next couple slides. The next levels are technical support. So these people, generally, they'll have their bachelor's degree. So George, he's a research technician. That's someone that's going to help you run your experiments day to day in the lab. We have Katie. Now Katie, she is a light microscope technical assistant. Every single person in our institute, if you want to get that beautiful image that we looked at earlier, you need to go and talk to Katie. Katie's the person that's going to troubleshoot everything for you. Katie came to us as a high school intern. She applied for the mechanical engineering internship that we had. She was working at a mechanic shop fixing outboard motors. And she figured this is the only way she was going to get her foot in the door with us. And my supervisor met her, said she needs to be working with the microscope. Now, Katie is currently pursuing her undergrad, so she's a college student. She works for us full-time still, because when she went to college, her professors actually said, you're going to learn more staying there. Take your courses at night. So she's getting paid, she's getting her undergrad at the same time, and she's someone that everyone depends on who does not have their degree yet. And then lastly, I have Abraham. Now Abraham, he's a CNC machinist. So what that means is it's a computer numerical controlled mill. It's a 5-axis mill basically. It makes really specific, really precise parts. Now Abraham, after he was done with high school, he joined the military. He did 3 tours in Iraq and Afghanistan, and he came back and he really lacked direction. He wasn't sure what he wanted to do next. Some of his friends became cops, some of his friends became firefighters, some of that's not for me. So he started working in a factory as a laborer. And when he was in the factory, one of the parts that they made was made on the CNC machine. He was really interested in it. He talked to the person who was the machinist there. He started getting some on-the-job experience. Once he decided, hey, machining, it's really interesting, I gotta do something new every day, he kept picking up these skills. They told him at night, go and get your certificate. He went to Palm Beach State College at night. He got his certificate in CNC machining, and he's now one of our lead technicians and someone we rely upon every single day who didn't have to pursue his higher degree to get it and got all of his training on the job. Next, we have animal care and institutional safety. You guys know I'm a scientist. You guys have all probably heard about lab rats in the past. We have to have someone that takes care of our animals. So we have Idris. He's a doctor of veterinary medicine. So he's a vet, went to get his degree in that. We have Eric, who's the head of environmental health and safety. Now, you guys probably can figure out that if I'm working in a science lab, there are probably a lot of things that we work with that you can't just put down the drain. We work with acids, we work with things that are radioactive sometimes, we work with some things that can be carcinogens if they're not treated properly. His job is to make sure that we're all doing things safely. And then the person I'm going to talk to you about is Anthony. So Anthony, right now, he's our lead technician for environmental health and safety. Anthony, when he finished high school, he needed to hit the ground running. He needed to work. That was his situation. He joined Max Planck as a cage washer. So think of in a restaurant, the dishwasher, same concept. It was the absolute lowest job. He took it, and he did what I'm encouraging all of you to do in every opportunity you ever have in your life. He made connections, and he tried to seize every opportunity that he had in front of him. So he was friendly, he was passionate, and he was excited about what he was doing. He ended up becoming an animal care tech. So he was taking care of the animals, he moved up in that. And now he's our number 2 in environmental health. He's moved up, so he's the person that handles all of those chemicals that I have no idea where to put. He is integral to every single thing that we do at the Institute. And again, he didn't get a degree. He got on-the-job training, and he seized opportunities that were put in front of him. Next, I'm going to talk to you guys about IT. I know that, especially this generation, you guys are on phones and tablets and computers. You guys all are more tech savvy than most people I know, probably. So we have a couple different routes you can take for IT. My first friend over here, he's another postdoctoral fellow. So he got his PhD. He got his PhD in data science. Because in research, if I take one image on a microscope, I have about 100,000 data points that I have to assess that's in that one image. Data is not something that I can just do in an Excel spreadsheet. I need someone that knows exactly what they're doing, and that's what Nico's job is. His job is to make sure that we can process all of that heavy information. He uses AI, he uses learning algorithms so that we can get the data we need out of it. We have Matthew, who's an IT tech. So just like you would think of, someone who does all of your computer support, sets up networks, things like that. And then we have Jacob. Jacob is a high school student. He was in our internship program. He's actually a junior in high school right now. Do I have any juniors? So he is still in high school. He finished his internship, and after his internship, his skill set was so defined by that 6 weeks that he spent with us that the lab decided to keep him on. So he was paid for his entire internship, and now he's still in high school and he's still being paid. And do you think that's going to look good on his college application? Yeah. It's going to look amazing. But the person I want to talk to you about on this slide is Matthew, because there's going to be a theme here of people that seized opportunities. So Matthew, he went to undergrad. He started pursuing his bachelor's degree, and he wasn't happy. It wasn't for him. He knew that it wasn't for him, and he ended up dropping out. He got a job at Max Planck in our security department. So he was checking people in at the desk, but he always really loved computers. So all of his IT skills are completely self-taught. It's all stuff that he learned by watching YouTube videos, by doing trainings that he found for free online. And then he made connections, he seized opportunities. He hung out with all the guys in IT. He started learning new things. Anytime they needed help with something, he volunteered. And eventually, he became an IT technician. They brought him over into their department with no formal IT training. He learned all of his skills on the job by making connections and seizing opportunities. And Matthew, I will say, I know it's being recorded, so this is probably not good. If I call IT, I want Matthew, I don't want anybody else. He's the best one we have. And then I'm going to talk to you about communications. Because again, I bet all of you are on social media, at least in some variety. So science, I told you before, we need to raise money to do science. We're a nonprofit. If we don't get grants and donations, science doesn't happen, progress doesn't happen. But here's the thing. If you've ever tried to read a scientific paper, if you're not a field expert, it's not going to make any sense to you. A lot of it doesn't make a lot of sense to me, because if it's not my specialty, I can't comprehend it. Their job is to take this information and make it digestible for an audience of the public. So we have Katie, she's our VP of Public Engagement. We have Kevin, our Digital Media Manager, and we have Leslie, she's the only PhD up there. She's our Scientific Communication Specialist. She reads those papers, translates it to English, and helps us out. But the person I want to talk to you about is Kevin. So Kevin, he did get his bachelor's degree in communication. So he started on the right track for what he's ending up doing now. But then he decided to go back and get his master's degree in psychology. He became a licensed counselor. He spent 10 years working in psychology, working as a counselor. But his passion was being creative. His passion was communication. So he started doing the same thing that Matthew did. He started learning things on YouTube by going on Reddit threads to try and learn more about AV and digital media. He eventually joined an AV department, started picking up some more skills. He came to Max Planck, where he was in the AV department. They very quickly realized that he was talented in something other than just what he was hired to do. He made connections, he seized opportunities. And now if you ever go to our website, which I encourage you to do because it's really interesting, all of our videos are made by Kevin, and they are all absolutely visually stunning, and they also communicate our science in a really effective way that breaks it down in a way that everyone can understand. And between these three people, I'm telling you, we wouldn't have half the funding we do if it was not for the people that are on this screen. And again, seizing opportunities, making connections. So before I move on, I just wanted to say that there are all different ways to be involved in science. The government, they do an assay every year about the different career fields that are growing the most. In STEM, in the next 15 years, is projected to be the biggest growth sector. So even if you don't think science is for you, is IT for you? Is communications for you? Is animal care for you? There's so many different facets that support this industry. And just as an example, I work at Max Planck. If I look out my desk window, I see Scripps. That's another institute, that's another 500 scientists that need support. If I look across the street the other way, there's the FAU Brain Institute. That's in 1/4 mile radius. You have 3 institutes that all need all of these people. There are so many opportunities here, and there are so many different ways to do it. Science isn't something that's unattainable by any means. It's something that all you have to do is make connections and seize opportunities when they come in front of you. So I'm going to talk to you a little bit about some of the things that we have going on in the community. I mentioned it earlier, but we do have a high school summer internship. This is a paid internship. It is open to students in Palm Beach and Martin counties. You guys are in Palm Beach County. I understand that it's an hour away. I do. I also know that I have students that take our internship that are in Boca, and that's an hour away, and it's in traffic. So it's a heck of a lot worse than my drive was this morning, I can tell you that. This high school internship, we have mechanical engineering, so you can work in the machine shop. We have data science, scientific programming, so you'd be working with our IT professionals. And then we have neuroscience, where you'd be in the lab getting your hands dirty doing the bench science. We also have the annual Brain Bee. So the Brain Bee, if you like trivia, Brain Bee is for you. It's a big trivia contest. You have teams of 3. We give you the study materials. You look into it. There are cash prizes for our 3 winning teams. And teachers, when you enter a team in the Brain Bee, there is a raffle for a $1,000 STEM prize. So that goes to whoever, regardless of how well any team does. So it's always a little bit of an incentive there. And this is open to middle school and high school students in Palm Beach and Martin counties. And the last one we have is Brain Exploration Day. Brain Exploration Day is an open house. If you've ever just wanted to see what the heck a lab looks like, this is the time. So almost every single one of our scientists volunteers for this event. We have over 100 of them. And their job at this event is to make a hands-on activity that explains their science to the common person. You can see I have a small friend there playing with some VR. He's actually exploring a fly brain using some VR and some electron microscopy. So I hope that's the end of my little talk here. I hope that you guys might have seen some opportunities that you didn't necessarily think of when you thought of science. And I'm happy to take any questions for you guys. I know that it's a lot I threw at you.
First of all, thank you so much.
You're very welcome.
I'd like to know, first of all, there was something that Dr. Eggerman said, Mrs. Eggerman said multiple times. Did you pick up on what the theme of the presentation was, above and beyond science? What did she say over and over? Seize opportunities, network, right? Make connections. That's super important. And did you hear some of the people that are actually working at Max Planck start straight from high school, right? And started with internship opportunities straight into high school. I was interested with the one person that you said their professor told them you're learning more working on the job and taking classes at night than if you were to just, so it's interesting. Any questions specifically about the brain research that she does? Somebody has a question.
Y'all tried it on the human yet?
So actually, I think you're talking about optogenetics, the light switch.
Yeah.
So that light switch protein, it's actually really interesting. It has been used in humans to cure one very specific kind of blindness. So there's one kind of blindness where basically your retina doesn't connect to your optic nerve, because there's one cell that connects those two things, and it doesn't fire the way it's supposed to. So optogenetics, what you need is you need this protein, and you need light. Excuse me. So this protein, they can actually inject it. So this person, they get a shot in that one cell, and then all of a sudden that cell is now going to be light responsive, just like how your eyes actually work. And it's cured this one very specific type of blindness. Now what's really cool about that is I told you, I'm basic research. I'm not applied. I'm not here to cure anything. I'm here to figure out how it works. For something to go from a discovery to a cure in humans in 20 years is ridiculous. I can tell you that in your lifetime, you're gonna see this technique win the Nobel Prize. That's how important it's gonna be.
How do you isolate that into a cell? If you change how do you get into that particular?
So we have methods for genetic engineering, where basically we can set really specific processes of breeding to get them in there, but we can also do it with injecting using a virus to get the DNA into the cell that we need it to be in. Pardon? So for that particular cure, I don't believe I've heard of any, but also I'm not a medical professional, so I only know that it has been used for that. I haven't actually seen the studies that it's been done with. One thing that's really important that if you ever meet another scientist, you're gonna hear a lot is, I don't have the answer to that. Where the one thing that you wanna do in science is always, admit when you don't know something, because you never wanna speak out of turn.
Anybody else have a question?
I was curious, do you necessarily
Oh, that's a really good question. So the question was, were you a straight A student in school? And the answer is a hard no. When it comes to writing, when it comes to history, they just didn't interest me. And so I didn't try very hard. Science is one of those things, I can say science and math, they came easy to me. I think everyone has something that comes easy to them, right? It might be sports, it might be writing, it might be music. Science and math are what came easy to me. And so if you have something that comes easy to you, absolutely try and find a way to make that your passion. Because I get to do what is easy for me and what I love to do. And is it always easy? Absolutely not. But at least I have a firm background in it. But when I went to college, I had to retake courses. I had to retake systems physiology almost twice. But I got through it that second time. There are all different levels when it comes to academic ability, and no one expects you to come into something knowing everything. Because no matter what, my organic chemistry that I took in college, I don't use that on a day-to-day basis. So the fact that I wasn't excellent at it, no one really cares about. They want to make sure I have the basics.